So we're getting into section 9 of weighted averages, and the third learning target is students will be able to solve distance problems. Now, there are three types of distance problems. There's a total distance, there's a round trip distance, and a catch-up distance. Okay, so we'll take at least one example for each. So read this distance example number 1. After a math meeting, Mr. Joe and Mrs. Miller leave from Old Orchard at the same time. Mr. Joe heads southbound to his home, whereas Mrs. Miller heads northbound to her home. Mr. Joe drives 35 miles per hour and Mrs. Miller drives 28 miles per hour. In how many hours will they be 252 miles apart? Now, you can draw a picture for these things if it makes sense. Now, I can't draw up and down, but draw a picture of the situation. If this is where OOJH is, then Mr. Joe drives one direction at 35 miles per hour, and then Mrs. Miller drives the other direction at 25 miles per hour. So this is an example of total distance because they went opposite directions, and we know that in between their two destinations is 252 miles apart. So I'm going to scroll down a little bit so that we kind of continue on with our example here. Now, since it's a total distance, that means we know that the person of the first distance, the distance 1, and the distance of the second person, when we add that together, is going to equal the total. Okay, so we know that we can use this. Now, you can create a table here to kind of organize your information. So Mrs. Miller, she's going 25 miles per hour. Mr. Joe is going 35 miles per hour. And the time is something that we don't know. Okay, but we know that they're both traveling at the same time. Now, if you don't know the formula for rate and time, rate times time is equal to the distance. So 25 miles per hour, 25 times the number of hours, means I'm going 25 times h. And so 35 times h will give me 35h. And so it doesn't matter who distance 1 is, but we can assign Mrs. Miller as distance 1 and Mr. Joe as distance 2. So if distance 1 plus distance 2 is the total, then that means 25h plus 35h is equal to the total, which is 252 miles. So there's my equation, and we're solving for the number of hours h. So go ahead, take a minute to solve that. But the most important thing is that you understand the setup of the equation, because solving the equation is very easy. So make sure you understand the setup. If you don't, pause, take a moment, and then rewind a little bit just to kind of gather your thoughts of why total distance makes sense like this. So after solving it, we see that it will take 4.2 hours for them to be 252 miles apart. So that's an example of total distance. Let's move on to the next example. Example number 2 says a passenger train and a freight train start at the same time, but they are 405 miles apart from each other. They travel towards one another, and pass each other in 3 hours. So that's the time right there. This is the time. The passenger train is going twice as fast as the freight train. How fast is each train traveling? So here's train number 1, and so here's a passenger train going this way, and here is the freight train going that way. And so they meet right here in 3 hours. And so we know this is also an example of total distance problem. So we're going to use a table here, and I'm going to give you a blank one to kind of help organize your thoughts. These two rows here, it's what are the two types of trains. We have the passenger train and the freight train. And again, we have rate times time is equal to the distance. So that's my chart, and I'm just going to fill in the table. Okay, so my rate of the passenger train, we don't know it, right? But it says it's going twice as fast as my freight train. So if my freight train, let's say, is R, which I don't know, my passenger train is going twice that speed. So twice that speed means it's 2 times R. And then the time for both of them, they started at the same time and they're traveling the same time. They're both traveling 3 hours. And so since rate times time is equal to distance, then I have for my passenger train 2R times 3, which is 6R. And I have R times 3, which is 3R. Now, since they started apart from one another and we're seeing where they meet somewhere in the middle, these two distances are added together to get the 405 miles where they started apart from each other. So that's the setup of the problem. D1 plus D2 is equal to the total distance. So if you didn't get that setup, if you didn't understand it, again, I would suggest pausing the video, rewind a little bit, or pause the video, reread the problem, read through the problem multiple times to try to capture what it's saying. Because solving this problem is very easy. I'm going to go ahead and solve the problem. You can go ahead and pause the video and solve it as well if you're ready to do that. So I solved it, combined the like terms, divided by 9, and I got R is equal to 45. Now the R, if you go back to the table, represented the rate of the freight train. So the freight train travels at 45 miles per hour, and since the passenger train doubled that speed, it is traveling at 90 miles per hour. So those two examples are examples of total distance. Now example number 3 is a different type of distance. It says, over the weekend, Mr. Joe and his wife are taking a trip to Washington, D.C., which is true, by the way. I'm in Washington, D.C. right now making this video. Because of the wind, it only takes 2 hours to arrive in D.C., but takes 3 hours to travel back to Chicago. The rate coming back to Chicago is 86 miles per hour less than the rate going to Washington, D.C. How fast is the plane traveling from Chicago to Washington, D.C.? Now, this is an example of a round trip distance. So what that means is the distance from Chicago to Washington, D.C. is the same as the distance that's coming back, right? If I were to draw this drawing, okay, the distance from Chicago to Washington, D.C. is X amount of miles, right? But also, the distance from D.C. to Chicago is the same thing. So, a round trip distance, what's special about this is that the distance going there is equal to the distance coming back. And so let's fill in this table again. So going from Chicago to D.C. and then from D.C. to Chicago. And then again, the rate times time is equal to the distance. So let's fill in some of this chart here. It says because of the wind, it only takes 2 hours to arrive in DC. So from Chicago to DC, it takes 2 hours. And then on the way back, it takes 3 hours to arrive back in Chicago. Now the rate coming back to Chicago is 86 miles per hour less than the rate going to DC. So if the rate from Chicago to DC is represented by R, then DC to Chicago is R minus the 86, since it's 86 miles per hour less than. And so we have to think about, so rate times time gives me 2R from Chicago to DC, and from DC back to Chicago gives me 3 times R minus 86. And so distance 1 is equal to distance 2, meaning the 2r is equal to 3 times r minus 86. Okay, again, solving the problem is going to be very easy, but I just need you to kind of look at this setup and see if it makes sense to you. If it doesn't make sense, read through the problem again, look at the drawing, look at the table, look at this D1 is equal to D2, and try to think about round trip. Otherwise, go ahead and solve it. Once you solve it, you get r is equal to 258. If you go back to the table, the r represented the rate or how fast the plane was going from Chicago to Washington, D.C. If you read the question is asking that specific one. It doesn't care about from D.C. to Chicago. So the plane travels 258 miles per hour from Chicago to Washington, D.C., which is probably inaccurate. If it made sense to you, then move on to the final example. If it didn't make sense to you, pause, rewatch this example. There's no problem in that, okay? It says a ship left a port and sailed east at a rate of 20 miles per hour. 1 hour later, a second ship left the same port and sailed in the same direction, which was east, but traveling at 25 miles per hour. In how many hours will the second ship meet the first ship? So, if we were to draw a picture, there are two ships. The first ship is traveling east at 20 miles per hour. Now, 1 hour later, another ship leaves and travels at 25 miles per hour. And so it's just asking when will this second ship meet the first ship, since it is traveling a little bit faster, even though it left a little bit later. This is an example of a catch-up distance, since the second ship is catching up to the first one. Okay? Now, that also means that even though the second ship has traveled less time, they have traveled the same distance because they will meet at a certain place. So that again is D1, or distance 1 is equal to distance 2. And so the distances will be equal to each other since they will be at the same place after a certain number of hours. And so let's fill in the table here. On the left side I have two ships. Ship 1 and ship 2. And then again, distance formula is rate times time is equal to the distance. Now, we know the rate of the first ship is 20 miles per hour and the rate of the second ship is 25 miles per hour. If the first ship, we don't know how long it's been traveling, but let's just represent that as t. What we know about ship number 2 is that it left 1 hour later, which means it's been traveling 1 less hour. So it's been traveling 1 less hour than the first ship. So the t hours minus 1, right? So hopefully that makes sense to you. And then we just do the formula. Rate times time, 20 times t gives me 20t, and 25 times t minus 1 gives me 25 times t minus 1. And again, since they will both end up at the same place after a certain number of hours, these two distances are equal to each other. Okay, important part, setting up the problem. If you don't get the setup of this problem, pause. After you've written everything, copied everything down, pause it, rewatch this example, and then just kind of let it soak into your mind, okay? Otherwise, just go ahead and solve for t. Now, I got t is equal to 5. So ship number 1 has been traveling for 5 hours. Let me put that in a different color. So 5 hours. And that means ship number 2 has been traveling only for 4 hours. So let's look back at the question. It says, in how many hours will the second ship meet the first ship? So in how many hours? It's actually 4 hours, since that's how long the second ship has been traveling. Okay. So again, if you didn't understand this example, pause it, rewind to where you need to go. But the number of hours that the second ship meets the first ship is 4 hours. So those are four examples of the three different types: total distance, round trip, and catch up. Okay. You do have your homework packet. So I think about 4 questions with these types of distance problems.